Homework 2.3, Linear Functions and Slopes, video 6. Homework due Friday, May 22nd, 2020 at 11:59 p.m. Before we move into this next section, I need to correct something from the previous video. The content was good, the math that I told you was correct, but what I neglected to do was to update the problems associated with it. So, in the previous video, the problems where you take 2 points and create the equation of a line were 11, 12, and 13. So if you were looking at 6, 7, 8, 9, and 10, you realize that none of those problems were here's 2 points, go make the equation of a line. 6, 7, 8, 9, and 10 were here's a point and a slope, make point slope form and go forward. But questions 11, 12, and 13 are here's 2 points, make a slope, now make an equation. So my apologies for not catching that. Now, this 14, 15, and 16 are the correct problems for this video's topic, graphing the slope-intercept form. In other words, if you have slope-intercept form, you can use it to sketch a graph without using the graphing techniques I showed previously. For example, we're going to graph the function f of x equals 2/3 x minus 4, which is a linear function and it is in slope-intercept form. Previously, when we talked about graphing, I said there was a technique that will always work. It involved making a table, choosing some values for the x, substituting them into the function, getting the corresponding y values, putting all the dots and connecting them. But I also told you that the more you know in advance, the less work you have to do. I know a lot of stuff about this line because its equation is in slope-intercept form. What is the slope of this line? Hint, it's in slope-intercept form. I'm looking for my red marker in case you're wondering. Not the one up on the wall over there. Well, dang, where'd that red? Oh, here it is. Found it. What's the slope of this line? The slope is 2/3. What's this number? Hint, this is in slope-intercept form, so we know that the y-intercept is equal to -4. This is extremely valuable information. The fact that the y-intercept is -4 means that I can go down to -4 on the y-axis and put a dot. Hooray! I know this is a line, so I only need one other dot to connect. I'll find 2 more to make sure that the second one isn't wrong. But how are we going to find the other dot? Hint, we can use the slope. Because what is slope? Well, there's a lot of answers to that question. A measurement of steepness. y2 minus y1 over x2 minus x1. Rise over run. If we think of slope as rise over run, you can think of a slope as a set of directions, like on a map. A slope of 2/3 means I need to rise 2 and run 3. But if I'm going to rise 2 and run 3, from where do I rise 2 and run 3? The answer is any point that you already know is on the line, like this one. So if you have an equation or a function in slope-intercept form, you can start at the y-intercept, and then according to the slope, rise accordingly. So we're going to rise 2, and then run accordingly. We're going to run 3. So 1, 2, 3, and that'll put you at a new location. Now the y-intercept is 0, -4, but where is this new point? It's not 2, 3. Those are the directions I went. But when you measure the coordinates of a point, you always measure them from the origin. So 3, looks like 3, -2. Which also makes sense because from the -4 we went up 2, so now we're at -2. And from the 0 we went over 3, so we're at 3. Let's do the rise and the run thing one more time. From this point, let's rise 2 and run 3. So rise 2 puts us up on the x-axis, run 3. That puts us here. That looks like it's the point 0, 6. No, 6, 0. And all 3 of these points are collinear, which is exactly what it sounds like in a straight line. So, ta-da! There's the graph of that function. No table necessary, didn't have to choose any values. The y-intercept tells me where I can start, and the slope tells me which direction to go from there. I want to do one more real quick example because this video is, it's not that long and I'm not trying to make it a longer video, but there is something I need to warn you about. So So we're going to do this problem again, and in fact, we're going to do the exact same problem, but I'm going to change one thing. I'm going to put a negative on the slope. Now, what do we know about lines with negative slopes? Positive slope lines are increasing, but negative slope lines are decreasing. Well, what would that change over here? Well, when you have a negative on a fraction, you either put it in front, on the top, or on the bottom. And since I'm thinking of this fraction as two separate numbers, I need to put it on the top or the bottom. I will almost always put my negative on the top when I have to make a choice. So now, if our function is f of x equals negative 2/3 x minus 4, we didn't change the y-intercept, so our starting point is still going to be down here at negative 4 on the y-axis. But what impact will that negative have? And specifically, what impact will that negative have when we rise and run? How do you rise negative 2? It's kind of a misnomer, if you will. When you rise negative 2, you're not really going up, you're going down. Another way to think of this is go negative 2 in the y direction. So negative 2 in the y direction would not go up, it would go down. So with a negative slope, if you give the negative to the rise, that means you're going to go down, not up. So here, if we rise negative 2 and then run 3, we were originally at the point 0, negative 4, but do you know where we are now? Well, we were over 0 and we went 3 more to the right, so we're over 3. We were down 4 and we went down 2 more, so now we're down 6. And I'm not going to rise and run again. The point I was making was, if your slope is negative and you break the slope into rise and run, you have to give that negative to either. I will always give it to the rise. Could I have given it to the run? Sure. That just means I would have ran backwards but risen up, and it would have put me up here. But just for consistency, when I'm disassembling a slope into rise over run, and the slope is negative, I by default always give the negative to the rise. So instead of going up, it goes down. And we got what we were expecting. A line with a negative slope should be decreasing, and this one is. In the next video, I'm going to move the camera and show you how in the homework to do this. It's not that difficult to do. In fact, it's crazy easy. But since I'm making videos, I think demonstrating how to click the graphs in my labs in mastering to sketch the equation of a line that's in slope-intercept form, I just want to show it to you.